Yeah, so in this question, you have a box of mass 20 kg. Can you see it? Okay. A box of mass 20 kg. The coefficient of friction between the sidewalk and the box is 0.500. It's just this two zeros are put for the significant figures. Okay, and you are applying a force of 90 Newton. It's not 90 degree, 90 Newton at an angle 30 degrees. Okay, so you have to find out the acceleration of the box. And you know, acceleration is what? F is equal to ma. In that equation also you have to write. So we have summation fx is equal to ma. So a will be equal to summation fx over m. So let this be your first equation, and this is your second equation. So if you want to find the acceleration, you need. So what's the net force in the x direction here? So the force acting in the x direction are the x component of the applied force, that is F applied x. And when the box moves towards right, the frictional force will be opposing it, that is Fk. So the net force acting on the x direction is summation Fx. Summation or F net, both are same, okay? F applied x minus Fk. Why minus? Because it is acting in the opposite direction. And now you need to split this. You need to find this one individually. So F applied x is simple, F applied cos 30, because this is adjacent side, okay? And this is your F applied x, and this will be your F applied y, okay? All these colors will come. This is your F applied y, okay? Now I calculated F applied x. Next is your aim is what? You need to find out Fk. And you know Fk, the equation is Fk is equal to
coefficient.
Yeah, Fk is coefficient of kinetic friction mu k times Fm. So now our problem is mu k value is given 0.500, but Fn value we don't know. Fn you need to find out. So if you want to find out Fn, if there's no applied force, Fn is simply what? Fg. Since it is a horizontal surface, you can simply take Fg. But here that's not the case. Is it accelerating in the y direction or x direction? It's accelerating x direction only. So what's the acceleration in the y direction? 0. So if the acceleration is 0, what's the net force in the y direction? 0. So you can write summation Fy equal to 0, because there is no acceleration in the y direction. Now you can write all the forces acting in the y direction. That is equal to, what are the forces acting up? F applied y. Okay, the y component of the applied force is acting upwards. So you can write F applied y. And also you can write the normal force also acting up, isn't it? So plus Fm. And which force is acting down? Fg. The weight of the box is acting down. Not yet on joint. So that is equal to minus Fg. Equal to 0. Why is minus? Because it is acting down. Now you are looking for Fn only. These three terms sum is 0. So just keep Fn here. These two terms take to right hand side. So F normal will be equal to minus Fg will become plus Fg, and plus applied will become what? Minus y, right? Y. So Fg is simply what? Mg. Minus F applied y is F applied cos 30 or sin 30. This one is sin 30 because it's opposite side. Sin 30. That is equal to mass of the box is 20 times 9.8 minus F applied by is 90 sin 30. That is equal to
90 times
90 sin 30 is 45.
151.
151. Very good. So F normal is 151 Newton. Now since you have Fn, now you can plug it here. Okay, Fk in Fk. So Substitute the value of Fn in equation number 3. Substitute
151.
the value of Fk in equation 3. Then it is going to be Fk is equal to
Is equal to kinetic friction.
Fk is mu k times Fn. So mu k is 0.5550 times. Is there a unit for coefficient of friction? No, because it's a ratio between force of friction. You know, mu k is Fk over Fn. Both are force, so the unit will cancel. Okay, so this ratios won't be having any unit. So 0.5 times 151. So this is how much? 75.5 Newton. No, Fk. Now what we can do? Now we can substitute the value of Fk and F applied x in equation number 2. Okay. So now we'll go. So substitute the value of Fk and F applied x in equation 2. So that's going to be summation Fx is equal to F applied x is how much? 77.9 Newton minus Fk is 75.5. So this is going to be 2.4 Newton.
The summation of x equal to 2.
Yeah, summation Fx. Now you have acceleration is what?
Equals to
Summation
fx over
Fx over m.
mass.
So that is 2.4 divided by mass is 20 kg.
Yeah.
So that's going to be 0.
12.
Yeah, 0.12. Okay.
Negative because it's
Negative or positive?
negative. Actually, no positive.
Positive only because the net force is still acting in the positive direction. Okay, so 0.12 meter per second square. Okay, clear? And you should write it's to the right.
Right.
And in practice question number 1 is same as this one. Okay, do you want to take a picture of this one?
Since it down to the group.
Anyways, I'm recording it. Okay.
Still nice to send.
So practice. So I'm going to resist. Okay. Sarah and bike. Where do they go? They forgot about the class.
I think that's
I think someone is just sending messages, but I don't think. If it was them, it will come in your phone also. I'm erasing this, okay? Next, I will be doing practice question number 2. Question number 1 you can do is same as the sample question, okay? Practice. This is like nothing to worry. It's a little bit complicated compared to the sample question. This is practice C, page number 130. Page 139. Only when we do this difficult questions, like we get charged. Otherwise, we feel bored. A student in item 1. That means that question number 1. Okay. So in question number 1, what's the mass of the box? Mass is 35 kg. So that.
question.
Yeah. So student in item 1 moves the box up a ramp inclined at 12 degrees with the horizontal. So in this case, they are not moving the box through a horizontal surface. Now the ramp is inclined. Okay. So that's the main difference between the sample question and this one. So here you have a ramp that's inclined at 12 degrees. And you have your box of books, here. Maybe I think I will draw this a little bit big. Just 1 second. So this ramp is inclined at an angle 12 degree. Then if the box starts from rest at the bottom of the ramp and is pulled at an angle of 12 degree with respect to the incline with the same 185 Newton force. I'm not going to draw the box at the bottom, okay, because if I'm going to draw the box at the bottom, I cannot draw many things. Okay, so I'm just going to draw it here. So this is your box, and this force is what? Force of gravity, and this is equal to mg. My God, where is this RR bike? This is a very important question. I sent the message. I received that one. And this box is pulled at an angle how much? 25 degree. So this force. This is F applied. Okay. So this F applied equal to same as that in question number 1. How much? 185 Newton. And this angle is how much?
25.
Yeah. This ramp is inclined at an angle 25 degrees. And what else is given there? The acceleration, you have to calculate the acceleration, and the coefficient of friction is 0.27. So mu k equal to 0.27. You have to calculate the acceleration. So if you want to calculate the acceleration, same way, like you can consider this as x-axis, and the axis which is perpendicular to this plane of the ramp, you can take it as y-axis. Okay. So this is the y-axis. So you need first you need to find out summation fx is equal to ma. So a is summation fx over m. Okay, that's our equation number 1. Now you need to look at the net force acting along the x direction. So summation fx is equal to, just like before, this is F applied. So this F applied you can split. Okay, this is your F applied x. Any problem? No. And this is your F applied y. Okay. And same you can draw it over here. So this is going to be this F applied y. Okay. Don't think these are two different forces. Okay, I'm just showing this and this are same. Okay. And also, F normal also acting up. This one. F normal. And this is Fg. So this Fg now, this surface is inclined. So this Fg can split into two parts, isn't it? One is, you can see, this will be the x component of the gravitational force. So this will be Fgx. And this will be what? Fgy. Any problem? And this is your total gravitational force Fg. Don't be confused with this one and this one. This is your Fg. Okay. This is your Fgy. And since this angle is 12 degree, this angle also will be how much? 12. So now you have F applied y here, F normal here. This is your Fgy. This is Fgx. And if you are pulling the box up, in which direction the frictional force will act? Opposite to it. So Fk also acting along this direction. This is your Fk. So now what are the forces acting in the x direction? F applied x acting in the positive direction. F applied x. And what are the forces acting opposite to it? Fgx and fkg. So minus fgx minus fk. This is equation number 2. Now you have to calculate each one separately. Okay. So f applied x is equal to, see, this angle is 25 degree. This is the adjacent side for this one, isn't it? If you consider this right angle triangle, f applied x is equal to f applied cos 25 degree. Any problem in that? Because this is the adjacent side. So that is equal to f applied is 185 Newton. 185 Newton times
It should be 167.6.
167.6. 167.6. Okay, f applied x is. So that you get down to 168 because here the values are given 3 significant figures. Okay, so f applied, if I write on the bottom, zoom it won't cover. So a lot down here. Oh, I just finished it. So 168 Newton. F applied x. So this one finished. Now you need to find out fgx and the fk. Fgx is equal to see. Now look at the value of fg. Look here. If this is fg, this is your fgy, isn't it?
Yeah.
And the one, this is what? This is your fgx. And this value only, I mentioned it over here. This one only just coming here. It's same. So this fgx is, if this is this angle is 12 degree, this fgx is your opposite side or adjacent side? Opposite side. So if you consider this right angle triangle, here fgx is equal to, since it is opposite side, it is sine. Okay, fg sine 12 degree. Fg sine 12. So don't be confused why here x is cosine and here it is sine. You can see over here. Here the angle is coming here. Okay, so the x component is adjacent side. Here the angle is marked over here. So now the x component is what? The opposite side. Okay, just because where you took the angle. So ft sine 12. So ft is how much? Mg. So that is mg sine 12. M is how much? M is 35 kg. Times 9.81 times sine 12. So your
71.4.
so you can write as 71.4 Newton. That is your fgx. So now you have f applied x, fgx. Now what else is left? Fk is left. Okay. So you look for fk now. We have fk is equal to mu k times fn. Mu k is given. Now our aim is what? You have to find out the value of fn. Okay. If you want to find out fn, you have to look at the y-axis. Is it accelerating in the x direction or y direction? X direction. So since it is not accelerating in the y direction, the net force acting in the y direction should be 0. So we have summation fy equal to 0. And that's equal to, what are the forces acting up here? F applied y and F normal. F applied y plus F normal. And which one is acting down?
FGY.
FGY. Very good. Minus FGY. Some students may confuse it as FG. Okay, no. FG is like FGY, just opposite it. And this is equal to what? 0. So you are looking for Fn. So just keep Fn here and all other terms into other side. So your Fn will be equal to minus FGY will become plus FGY. FGY minus F applied y. FGY is simply mg Here, look at this FGY. This is adjacent side or opposite side for this 12 degree?
It's the adjacent.
Adjacent side. So this is FGY is mg cos 12 degree minus f applied y is what? F applied y here, look at this 25. This one is opposite side or adjacent side? Opposite side. So that's going to be a sine. Okay. So that is f applied sine 25. So that is equal to 35 times 9.81 times cos tau minus f applied is 185 Newton times sine 25. So how much is the value of f normal? I think it's 258.
151.
F normal?
Yeah.
Let me check. 150. Yeah. Sorry. I thought 35 times 9.81 times cos tau minus 185 sine 25. Yes. No. Did you f applied x was how much? F applied x is 168. Okay, correct.
Oh wait, 1 second.
And 300 FGY is how much?
FGY 0.
Once FGY is 35 times 9.81 times cos tau. It is 335.84 minus 336. You can take 336 minus 336 Newton. Okay, you check your calculation. And F applied Y is F applied Y. F applied is 185. 185 sine 25 is 78.18. So you can write 78.2. Now you just subtract 336 minus is 257.8. So you can write 258. Okay. Now once you have the F normal, now you can calculate Fk. Okay. So now substitute the value of F normal, the value here. There's the value. There we wrote So Fk is equal to mu k times Fn. Mu k is how much? 0.27. 0.27 times Fk is 258. So 0.27 times 258.
69.66.
69.61. Okay. So you can write 69.6. Yeah. 69.6.
I got 69.66.
Yeah, rounding. 6. Okay, you round 69.7. Okay. I'm getting 69.6 because of rounding maybe. Okay. No problem. So this is your Fk. Now you have the value of Fk. You have the value of F applied x. And you have the value of Fgx. Okay. Just substitute all these values in equation number 2. So now your summation fx is equal to, what's the value of F applied x? F applied x is 168 Newton. Minus, what's the value of Fgx? Fgx is 71.4 Newton. Minus, what's the value of Fk? It's not this time?
Almost.
Let's give me it's a
fine.
long problem. So what's the value of Fk? Fk is 69.6.
69.7.
7. Okay. I wrote here 69.6 as well. Okay. So now that is equal to 168 minus 71.4 minus 69.
7, we get 26.9.
Yeah, nearly 27. Okay, so this is 27 Newton. So now you have summation fx. If you have summation fx, then you just need acceleration. Acceleration is what? Summation fx over m. So that is equal to 27 Newton divided by our mass is 35 kg,
0.77.
0.77 meter per second square. Nice problem, isn't it? Thank you. Bye.
This
So the remaining questions we can do it as homework. Question number 1, 3, and 4. Okay. Bye. See you.